So in today's video, let's have a quick look at the digital earth tester MTD20KWe. Okay, how the connection is done and how testing is done in case of any substation. You can do it for your house also to test how strong is your or how good is your earthing. All right, so for testing, before going to the testing part, we will just quickly look at this instrument, actually what it does. Actually, if we see from this the selector switch, it's there, R, V and a row. It is for, and the first one is for measuring the earth resistance, okay, of the three poles of our substations that we have, RYB phases. It is for collectively be measuring for all of them only. So it will measure the connection, which we'll see later. And second is that it can be used for measurement of soil specific resistivity, and third, it can use for measuring spurious voltages which is caused by parasitic voltages, which normally in all substation these parasitic voltages are there, whether it's Killing substation, Maulai substation or Nehu substations. Okay, so depending on where we keep our selector switch, whether if we keep it in R, it will measure the resistance. If we keep it in V, we will be measuring the voltage, okay, the voltage with respect to earth of any equipment. And then if you put it in raw, it will be it will give you the measurement of the soil resistivity. And this is actually important when the initial construction, at the construction time, when they have to construct a substation, they'll have to do the soil testing. Okay, and this instrument, if you look at this instrument, the active and the passive filters used inside this instrument provides you the state-of-the-art system that would give high immunity to electric interferences, making this instrument possible to obtain reliable measurements even in the presence of spurious voltages, like I said, which is there in our substations. Okay, and there you see the charger also. It's provided. You can just plug from your domestic voltage, and it's the output is 12 volt DC. And you look at the left hand side of the equipment or the instrument, you will see there H, EC, S, ER, ES, EXT, and then E, EXE, and then the start for testing. All right, and the first one, H is actually called the current injection point. From here the output is taken. Whatever current that we are injecting, this H will be flowing to the ground, and it will return back from the neutral, I mean from the earthing. Okay, that the earth that we are intended to test, right? The earth which is under testing. Okay, it will be injected from this terminal H, and then S is called the voltage point. Okay, and the respective electrode will be called voltage electrode, and this is the output terminal. It's blue in color. The very first one, H, is red in color. The second one is blue in color. We have to remember that. And normally the meter length of H is 40 meter, and then that of S is provided with 20 meter wires. All right, now ES is also there, but this ES will be essential. This is also a voltage electrode, right? Will be essential. It is called the the voltage electrode, and it will be essential in case we want to measure the spurious voltage. All right, which in this case we will not be discussing about this, because we are only concerned about earth resistance, which is normally done by these people when they come from the inspectorate of electricity, whether it is our state or state of Assam. When they come and do this testing, they'll do only the first one is your isolation resistance, and second is your earth resistance. They will just be expert only in these two measurement. They'll not be measuring these SFRA test, DC CRM test, all those things. They will not have that much of an idea. But in case of IR test and resistance, it will be it's compulsory for them. Before giving clearance, they'll have to do it, right? Okay, we have just seen a little bit about this equipment. And why we're using these nomenclature H, S, E, S, E, because these are the standard nomenclature currently recommended by the International Electrotechnical Commission. We call it IEC. And one thing to note that when we keep the this function selector switch in our position, that means when this selector switch is kept in our position, then what happened in that case, this very terminal E that you see, this green one, and ES will internally be shorted. All right, that is when R is in when the selector switch is in R position, E and ES will be internally shorted, whether the internal battery of this equipment has enough charge or not. You can see that by just pressing the battery test push button. It will show you the status in the display. All right, now if the value that shows in this display when you press this button is less than 1000, that means there is the charge inside the battery is not enough, right? Then you have to charge it. Okay, and this process actually has to be repeated for each test. All right, now we go from one pit to the other. You have to, the very first thing is to press this battery just to see the battery status. All right, you should get a value of more than 1000 here. All right, if it's less, then you have to charge it, and or the best way is to keep charging it, right? Every time you test it, you charge also. And then just like I said, you can just charge from your domestic supply of 230 volt AC also. All right, now for knowing that, in a display, it will, when you charge it, it will display light alternate red and green will be becoming, it will keep showing you light alternately, right? Like that means it's still checking the battery status. Okay, and if it comes as red, then it means that the equipment is not yet charged, it's still under charge, it's still charging. All right, the moment, because of the microprocessor base inside, the program is there, that the moment it becomes green, that means it's the battery is under a float system where the battery is fully charged and it's not a charge anymore, right? Because it's fully charged. All right, now when you do the testing, sometime when we insert the electrode, we'll come to that. You will be experiencing this acoustic sound alarm or beeping. All right, now this is an indication that the connection has not been done properly, or in our case, like it happened in Killing or Nehu or Maulai, when we did the test, actually we did not insert the electrode properly. So what I did was that I just hammer it properly, and then I use series also to clean the earthing surface, and then you connect it properly, and then the sound will not come. All right, when you do the test, when you just press this start button, it will just give you the value. All right, in this test we are going to measure the resistance of this 132 kV Maulai substations by keeping our voltage electrode at a distance of 10 meter from the earthing pit, the blue one, and then we will keep our current electrode at a distance of 20 meter, twice of the voltage electrode, that is 20 meter from the earthing pit, like this. And then let us go and see the measurement, that is the reading, how much is the resistance, and it will be obvious that the moment you keep it at higher distances, your resistance, as per the formula, will be lesser as compared to the one at lesser distance. So we are going to we are going to get lesser values. Okay, if we just look it properly, I think we will be getting in 0.23, 0.24, just like we did in Killing, which we will see that also. So CR value is 0.23. all right, let me take 0.23, which is a very good resistance value. All right, so this is how we are getting, and the distance will keep increasing if we reduce the distance, just like in this case I have reduced it, the current electrode to 10 meter, and then the voltage electrode to half of it, that is 5 meter, and this is the reading. All right, 8.5. it will be, if I reduce it by half the distance, and the resistance will also increase by the same proportion, like this. All right, and now if I reduce the distance, I'll keep on reducing like this. I'll keep it at 5 meter and 2.5 meter. let's see, in our case we are keeping the uh, yes 2.5, and 2.5 is our voltage electrode, and point and 5 is our current electrode, like this. And then we are going to see the reading. It will be slightly on the higher side, all right, because depending on the distance, that's why distance is quite important. So our reading is going up, see, now it's 0.77, see, right, it's 0.77. So we will keep on reducing our distance, to our this is the one that this is the standard so when you have to measure the resistance, and the instrument has to be connected like this, okay, your voltage electrode, the voltage cable has to be placed at a distance of 1 meter from the center point of your earthing pit, which is under measurement. Just keep it at 1 meter, and then in a straight line you insert your current rod also, the red one, twice the distance, because this voltage rod will be at a distance of 1 meter, and your current rod should be at a distance of 2 meter. And this is actually the standard distance that you have to keep your current rod and voltage rod, and this is actually done by MRT people also when they have to do the resistance measurement. And for each earth pit, for each earth pit like this, you have to take 4 readings, okay. One will be the east direction, 1 meter your voltage rod, and at 2 meter your current rod, and then your earth connected like this, the connection like I have shown you, and you have to take the reading for the east direction. And in the same way you do for west direction, north direction, and south direction. So for each earth pit you will be getting 4 readings, and then you just have to take the average, all right. And you have to do for other pits also like this, because in every substations we have earth pits, all right. For example, in our Killing substation we have so many earth pits. Even in this 132 kV switch yard also so many, because it's quite big also, no. And in our 400 kV switch yard also we have so many. In this 220, we have lots and lots of these earthing pits. And for example, in Molai, 132 kV Molai substations also, they have around 5 to 6 earth pits, all right. And the same thing they do here also. So this is what you have to do, and you just have to take the average, all right. If I have to summarize the entire thing into 30 seconds, then what you have to do, you have to connect the instrument like this. Your current electrode edge has to be connected at a distance of 2 meter from the center of the earthing pit, and your voltage electrode at a distance of 1 meter from the earthing pit. And you have to do for all the directions, north, east, south, west, all right. And then while doing this, you will be getting 4 readings, and then you just have to take the average of the 4, and then that is your resistance for that particular pit. And you can do this for other pits also, all right. So thank you.